Let's take like half an hour, 45 minutes and look at some of my favorite stuff of what's new in SQL Server 2019. I can't possibly cover everything that's in SQL Server 2019. It's a huge release. There's all kinds of cool stuff in it. But I'm going to focus on the things that I think are going to make the biggest difference for you if you're a database person who's inheriting apps that already exist and you don't have the ability to go through and change all kind of code. You just want to know how SQL Server 2019 is going to perform with your existing applications. So I've got the demo code over at brentozar.com/go/what's new. I'm just going to jump right in. I've already created a few indexes here. And for the first thing that we're going to start with is table variables. For the longest time, people have been telling you from videos and blog posts that you should probably avoid table variables. They perform okay when they only have one row in them. For example, here I've declared a table variable that's only got one row in it. If I look over at the execution plan, SQL Server inserts the one row into it, but then when I go to scan what comes back out of it, I can hover my mouse over there and it shows the estimated number of rows is 1, actual number of rows is 1. So far, so good. But when I switch over and I try to put multiple rows inside there, so for example, let's say that I put in 5 rows, all 5 rows come back, but if I look at the execution plan after my 5 rows are inserted, if I hover my mouse over that, look at estimated number of rows, there's only just 1. SQL Server would only expect that only 1 row was going to come out of this table variable, no matter how many rows were in it. This led to some very bad cardinality estimation problems, where SQL Server would think, as you joined a table variable to other stuff, SQL Server would think that it was going to be a lightweight operation, wouldn't take much work. Now maybe you're thinking, hey Brent, I noticed that you're making this demo on SQL Server 2019 and the behavior is still the same. Well, the reason why for that is SQL Server bundles all kinds of cool stuff under the compatibility level switch at the database level. This is freaking awesome. This is fantastic because if I go into one of my databases, right now I'm working with Stack Overflow 2013. If I go into one of my databases, right click and go into properties, there's this compatibility level switch. And you'll notice that even on 2019, I've got compatibility levels going all the way back to SQL Server 2008. Microsoft's apparent new mission is to make it easy as possible for you to spend money with them. They want to make it easy for you to move your existing old databases up to 2019 and know that they're going to perform the same way. So for example here, my current database compatibility level is 2017. So you see my execution plan behaving just as if I still had SQL Server 2017. Microsoft's goal here is that vendors should be able to certify their apps not on a version of SQL Server, but on a compatibility level so that they can more easily upgrade and know that their clients can upgrade. So what I'm going to do is I'm going to change my compat level to 2019. Now the way that I'm going to do it is I'm going to run this alter database compat level string here instead. This sets my database level to 2019. And now when I run the exact same query, execute it again, throw 5 rows into my table variable, and then hover my mouse over the select. Now you notice that estimated number of rows is magically 5. This is awesome. I didn't have to change my code at all. SQL Server just got smarter about how many rows come back from execution plans. Now, this is really good for those of us who use table variables in a real practical way. Like this is just a simple demo that only throws a few rows into a table. But let's do something that's much more like real world stuff that you would actually go out and do. I'm going to create this stored procedure. I'm going to go back and show you the contents here in a second. I'm going to run it under 2017. I'm going to flip my database compat level back 1, and then I'm going to go run this stored procedure. While it runs, I'm going to show you the stored procedure because it ain't fast. In this stored procedure, what I'm doing is I'm taking a location, any location from the Stack Overflow database, so where people say they are, London, China, the United Kingdom, whatever. I'm inserting in all of the people whose location is like that, and then I'm going and getting the top 1,000 posts from that location. Historically, in the past, this has presented a problem. If I look at the execution plan, the first thing that SQL Server did when we got all the list of people in a given location, SQL Server put in those 8,000 people into that one location. So I'm into that one table variable. So I just did an insert with like 8,700 people into a table variable. Now, if I look lower in the execution plan, the second query, when we go get stuff back out of that table variable, look at estimated number of rows there was only 1, but 8,000 rows came back. Now, as a result, SQL Server made every other decision inside this execution plan wrong. It chose things the wrong way because it only thought 1 row was going to come back from the table variable. For example, my sort ends up spilling to disk and writing the 250,000 AK pages off to disk. No bueno. So now, if that query took 12 seconds in order to execute, the only thing that I'm going to change in here is I'm going to switch around and turn into compat level 2019, and then I'm going to rerun the query again for exactly the same location. I don't want you to think that this is a pages are now cached in memory thing either, because that's not what it is. If you take these demo scripts and play along at home, you can see that the sudden quickness of this query, now runs in 2 seconds, has nothing to do with the fact that it was run back to back. The quickness of this query has everything to do with this sort, still spills to disk, but it only writes 20,000 pages instead of 200,000 pages to TempDB. And the reason why it spills less is because SQL Server accurately estimates now how many rows are going to come back from that table variable. Now it estimates that 8,700 rows are going to come back, so it's allowed to make different decisions through the execution plan, including how much memory it grants to queries. This query now, or this stored procedure, got a higher memory grant in order to deal with the larger number of rows. So awesome. Table variables are suddenly better in SQL Server 2019. There's a little bit of a drawback. So I've been running it for United States back to back, and you've noticed that I've had about 8,700 rows in this table variable. Well, there's a new problem. What I'm going to do is I'm going to run it for a different location. I'm going to run it for Boston, Massachusetts. And if I look over at the execution plan, the new problem is that the number of rows coming out of the table variable, the estimate there of 8,704 is from the first time that I ran this stored procedure. Stored procedures, functions, anything with table variables have a new problem, which is parameter sniffing. They are going to get sniffed for the first time that they get called, the first set of parameters they get called with. If you've been hanging around my blog for a while, you know that parameter sniffing is probably the #1 performance tuning problem out there. People are constantly going, why was the query slow a minute ago and now it's fast? Or why was it fast a minute ago and now it's slow? And I swear nothing changed. Because depending on whatever plan gets cached first, that's going to determine the estimates that everyone uses. Now, I still like this better than the problem that we had before with table variables before with their hard-coded 1-row estimate, because now at least I might get a better plan. It's just that sometimes it might still be crappy. Now, in the past, historically, SQL Server's had a lot of interesting fixes for that, or had a lot of challenging fixes for that. I'm going to go back to 2017, and I'm going to go run that United States query again. If you remember, it takes like 12 seconds in order to run. Now, SQL Server is slow on this because it underestimates how much memory this query really needs. It thinks that only 1 row is going to come back from that table variable, when in reality thousands do. So this sort doesn't get enough RAM to run, and it needs writes a couple 100,000 AK pages to disk. The reason why is because it didn't get granted enough memory. If I go over to the properties of this plan, SQL Server only desires about 2 megabytes of RAM in order to run this query. He uses a good chunk of that and then ends up spilling it to disk, spilling the rest to disk. In the past, in 2017 and prior versions, you're probably still on 2017, so it's not really the past for you. But in the past, when we rerun the same query over and over again, I like to think of SQL Server as an eternal optimist, where it's like, maybe it'll be enough memory this time. It tries to run the query again, and it spills to disk again, and it's still terribly slow. You would think that SQL Server would be learning a lesson at some point inside here and raising the amount of memory that it would give to a query. I know when I was a database administrator, I always assumed that if a query needed more memory, it would just go grab more memory, but that's not how it works. Memory grants are kind of ride or die. But starting in SQL Server 2019, there's a new tool that will automatically adapt the amount of RAM that we get, which is pretty freaking spiffy. So I'm going to switch over to SQL Server 2019 compatibility level, and then I'm going to go run United States again. Let's go look at the memory grant for this query. I'm going to right click on the select and go into properties. And under over memory grant, this time, remember these are measured in kilobytes, so we're looking at Microsoft, would it kill you to put some commas in here? We're looking at about 1.3 gigs of RAM that was granted to this query. Or it was 1.3 gigs that was desired, 1.3 gigs was requested, and then the query grant that was actually given was 1.3 gigs. Whenever Microsoft renders stuff in a properties list, it's either done in alphabetical order or they load up the data shotgun and just fire the data randomly at the screen. Both of those are bad for storytelling and investigation, but here it's in alphabetical order, so I kind of got to jump around. Now there's a new line inside here in 2019 plans. Is memory grant feedback adjusted? Someone's paid by the letter in here somewhere. And it says no first execution, meaning no, this is the first time that this query has been executed. So remember something for a second. We're looking at a 1.3 gig memory grant. Let's go run the query again, and let's go see what happens. Now let's go over and look at the execution plan, look at the select, and look at his memory grant. And now it's different. So now, golly, I would love some commas inside here. 2.2 gigs worth of RAM. The amount of memory we got granted went up. And if you remember last time, we spilled to disk, but we only spilled like 20,000 pages to disk. Now there's no yellow bang on the sort. We don't even spill to disk. The memory grant is adjusting. This is kind of cool. So 1.3 gigs the first time, 2.2 gigs the second time. Let's see how much we get the third time. Maybe third time's the charm. So if I go over and look at the execution plan now, go over to the select and the memory grant, now it's gone back down. I love this. It's so cool. It's dynamically adjusting the memory grant each time, trying to figure out where the exact sweet spot is. Because see, there's a penalty with memory grants. If I give you way too much RAM in order to execute your query, other queries won't get the RAM that they need because you lock all of it yourself. There's no sharing between queries during memory grants as they're executing. So this is cool. There's somebody back there, I like to imagine Joe Sack with a screwdriver inside the query engine, just turning it up and down, trying to find the exact sweet spot. And we can run this query over and over again in order for it to get to exactly the right amount of memory for this thing to run as quickly as possible, and yet we're paying as few of a price as possible for over memory grants to other queries. So that's pretty nifty. Except there's a drawback to this one too. I've been running this over and over for the United States. But I don't know about you though. Usually queries with parameters, my users don't seem to use the same parameter every time. So let's see what happens when we turn around and run it for our friends in Boston again. Now, if I go look at the query plan, I actually get a little yellow bang here on the select. Warning, the query memory grant detected excessive grant, as in like excessive grant fritchie. There's way too much grant fritchie inside this query plan. If I look at the memory grant for here, it's 794 megs, which reflects the goals that were involved with the United States. SQL Server was working hard to precisely tune the grants for the United States, but things are different now. This query just only used 3 megabytes, not gigs, 3 megabytes of RAM. So if I run it again, run it for Boston again, and go look at the execution plan, the grant that this select is getting now, now we're down to just 24 megabytes. What's going to happen when someone turns around and runs it for the United States again? Now, and don't be fooled, this thing ran very quickly. Mike got a pretty quick server. He's able to spill a lot of stuff to disk quickly. Now, operator used tempdb to spill to disk. We wrote 54,000 pages to disk. If I go look at the memory grant, when someone ran it for the United States, it only got granted 25 megabytes worth of RAM. If we run it for the United States a few more times, run it a few more times in here, and maybe it's going to stabilize on something where the United States will consistently run quickly. I'm going to go click on the select, go look at my memory grant, and now my memory grant is back up over a gig. And of course, you know what's going to happen when I turn around and run it for Boston once or twice. Now, all of a sudden, if I go look at the selects memory grant again, we're back down to 24 megs. Adaptive memory grants mean that the memory that your query gets is based on the last person who ran the query. If the last person ran United States, you get a large memory grant. If the last person ran Boston, you get a tiny memory grant. Now this stands to produce some problems for us because, again, remember how I said that the number one performance problem that we keep running into and out in the public is parameter sniffing, where plans are highly variable all the time and people don't understand why they're not predictable and fast. Here, they're very unpredictable. This also means that when someone comes running into you and says, hey, why is this query slow? And you turn around and you run it and it's fast, the reason that it's fast is that you're getting a different execution plan memory grant based on their parameters. So I guess you could tell the help desk, hey, anytime somebody calls in asking for a slow query, make sure that they run it twice. And it'll be fast the second time. But that's not very proactive. What you really need to do is you need to find out who like the admin assistants are for the big executives in your company. You need to have those admin assistants listen at their executives' doors. So whenever the executive says I'm going to go run a sales report for Boston for last year, you need to have that admin assistant leap into action and go start running the report for Boston. So maybe if by the time that the executive gets to the keyboard, they'll get a good accurate memory grant. Who knows? I'm not very popular with people who do troubleshooting, but that's certainly one way you could approach it. Now, another thing that's been really frustrating with these kinds of problems in the past is if I wanted to troubleshoot parameter sniffing issues, if I go to look in the plan cache, if I go to run tools like SP Blitz Cache, Glenberry's diagnostic scripts, any kind of third-party monitoring tool that looks at the plan cache, I was only able to see the estimated execution plan. When I went to go look in the plan cache, I'm going to highlight Boston again, and I'm going to hit Control-L to display the estimated plan. This was the kind of plan that I would see. Now, this execution plan has the shape of the plan that's going to run out in production, but it's only the shape. It doesn't tell me about, for example, if I hover my mouse over the sort, it doesn't tell me anything about whether that thing spilled to disk or not. So as a result, it was really hard to look at these execution plans and understand whether we were having problems spilling to disk or not. I just didn't know. And even if I did know we were spilling to disk, I didn't know which operator was doing it and why it was doing it, like how many rows were flowing through different parts of the execution plan. So SQL Server 2019 has a really cool feature for that as well. Right at the beginning of the demo, you may have seen that I had this command in here. Oops, so let me stop that here real quick. I don't want actual execution plans for SP Blitz Cache. So I had this statement in here that I ran setting up as part of the demo, alter database scoped configuration, set last query plan stats on. It's not on by default. It's a database scoped config, so it's going to run just inside Stack Overflow here. When I turn it on, that means that in tools like SP Blitz Cache, when I go look at query plans, normally when I click on this right here, I would see the estimated plan. But now when I click on this, I see the actual query plan. Dun, dun, dun. So now I can see, notice how these have exact number of rows flowing through here, like 754 of 1,000. And if I hover my mouse, in this case it didn't spill to disk, well, let's go make it spill to disk. So what I'm going to say is I'm going to go run it up for Boston a couple of times. Let's go run it for Boston a couple of times so that I get the nice tiny memory grants. And then I'm going to go run it for United States so that this thing spills to disk. Takes a little while in order to run. Now let's go run back and run SP Blitz Cache. Let's pretend like someone just called us up and said, hey, why is the server running really slowly? I can go look in SP Blitz Cache, look at that stored procedure, look at his query plan, and now I can see, as I move this around here, now I can see, ta-da, the sort spilled to disk, and I can hover my mouse over it and I can... Well, look, it's better than nothing. It doesn't tell me the number of pages that spilled to disk. It does just say, warning, I used tempdb to spill data during execution. And if I hover my mouse over some of the operators coming into here, I can kind of understand how big of a variance it was. These actual plans, I like to call them air quote actual plans. They're pretty close to actual plans. If you go over into the properties, there are a lot of things that you get that normally you wouldn't get in an estimated plan. For example, like max used memory, but it doesn't tell you whether or not it's adjusting. For example, it doesn't tell you desired memory like normally an actual plan would, but this is better than nothing. You don't get wait stats, for example, in here either. You do get query time stats, then they're mostly right. So it's better than nothing, and I shouldn't look a gift horse in the mouth. I never understand why they say that, because horse breath can't possibly taste that good. The place that I didn't taste that good, I smell that good. I'm sure it doesn't taste good either. You wouldn't see me kissing a horse. I should probably stop going off script here. There is a DMV too that you can call for that if you want to see where SPBlitz cache is getting its data from. It's DM exec query plan stats, which sounds like something that's been around for forever, but that's brand new in SQL Server 2019. All right, so I'm going to turn that off because it has adverse impacts for the rest of the demos that I'm going to do, that keeping the last query plan cache, or keeping the last query plan stats on in cache. Then I'm going to create a function, use it in a stored procedure, and then I'm going to talk through it while it runs. So what I've done is I've created a scalar user-defined function called getVotesCount. I'm getting the number of votes that a particular person has cast over at Stack Overflow. This is a scalar function, meaning you pass in one value and you get one value back. Then I'm using it in a stored procedure saying, go get me the top 50 users whose get votes count equals 0. I'm looking for people who haven't cast a vote yet. Now, for years, there have been all kinds of drawbacks with scalar functions. They run row by row, they hide in your execution plans, they don't show up in set statistics IO, they force the calling query to go single-threaded, meaning this stored procedure is going single-threaded regardless of how much work it's doing. Although ironically, what's happening inside the function can actually go multi-threaded. Because of this, for years, it's been a spectacularly bad idea to run functions inside of the where clause. These functions are going to run row by agonizing row, and this thing's going to take forever. If I go look at Task Manager, and go take a look at how the performance is going over on my CPUs. Woohoo! This is what we call bad. And I find that hilarious because as this thing goes and churns along for over a minute here, you saw me run select count star from votes and it took barely any time at all. Querying users is very quick. Querying votes is very quick. But when I combine these two things, the query finally finished after a minute 27. When I combine these two things, performance is absolutely terrible. So I want you to remember it took about a minute and a half in order to execute this. Now, the reason why is that SQL Server runs this function on a row-by-row basis. Microsoft got sick and tired of telling us, yo dog, you need to fix your functions, stop putting them in the where clause. They realized once they started to have to host your code over in Azure SQL DB, once I had to start hosting your code in Azure SQL DB, they went, oh my God, this code is terrible. It runs so slowly. It's burning up all this CPU, and we can't charge them for that. We should fix that in the engine. And they did. So now, all I'm going to change is I'm going to switch over to the brand new compat level. I'm going to switch this over to compat level 150, free my plan cache, and I'm going to run it again. Now, what SQL Server does in 2019 is that it inlines the function directly into your query plan. So now it only has to call that once. Now, it doesn't work for all scalar functions. There's a way that you can tell, that's listed in the notes here, as to whether or not your function is going to be a good fit for it, whether it even can be inlined. But then, this way, SQL Server is going to be able to inline it just once. Microsoft will be able to cut the CPU costs involved with hosting Azure, and then they'll be able to pass the savings. They're probably going to keep the savings, let's be honest. There hasn't been a price cut for Azure SQL DB since the thing came out. Meanwhile, hardware costs have been marching ever steadily cheaper, but I digress. Now, normally, you would think when something gets inlined and it only runs once, it should go faster. This isn't going faster. We're at 48 seconds now. To understand why it's actually not performing faster, I'm going to take this exact same stored procedure, I'm going to go into a new window, and I'm going to get the estimated execution plan, not the actual, just get the estimated execution plan. Those of you who are watching, keeping track, you can see executing going on there in the other tab while we work. Here's the brand new execution plan for our query. And there's something that's not in it. Now, the function is in it. So here's our select of the users table. And then this down here, this nested loops that hits the votes table, this is the thing that was in the function before. So this clustered index scan on the votes, it's now only done once, which is kind of awesome. The function has been inlined directly into my query plan. But there's something that you don't see on this execution plan. Parallelism. Now, yes, in the past, the general advice has been scalar functions go single-threaded, but the calling query goes single-threaded, not the function itself. In this case, my performance actually gets worse because what was inside the function used to go multi-threaded, but now it's pinned on just a single core. You might be thinking, oh, well, Brent, is it because it has a really low cost that SQL Server hasn't decided to parallelize it? No. Here I've got an estimated subtree cost of 1,100, and it's still not going multi-threaded. Finally, eventually, the query finished. The final tab on the query here was 1:44. It actually ran slower, not faster. Look, this is an edge case, and of course, you can hear all day long from all kinds of marketing presentations, look, it just runs faster, and maybe 99% of the time, it actually does. I high-five this feature, it's awesome, I absolutely love it. But not all of your functions will go faster. Some may go slower. And the robots are not going to put us out of work just yet if you go through and inline the function yourself. So what I've done here is I've taken the exact same query code and I've just inlined the function directly into my query by doing a left outer join. Now, when I go and execute that query, ta-da, runs nearly instantly. And when I go look at it, now I have parallelism inside my query, and I even get missing index recommendations on SQL Server waking up and realizing that there's a better way that it could execute this query. I don't even need to add the index at this point. If I get it down to sub-second operations, my users are probably ecstatic. All right, so what we've learned here is that there are a couple of features, table variables and scalar user-defined function inlining, that work, but they also have drawbacks. There are cases where it can make your query slower instead of faster. And we have new tools available to us in query execution plans that help us go see why queries are going slower or faster for queries that have already run. Let's take another one. Adaptive row store joins. So I'm going back over into SQL Server 2019, and I'm going to set up another stored procedure here. I'm going to go run it. Now, adaptive joins were something that first came out in SQL Server 2017 for column store tables in batch mode. But now we get them over in row store tables as well. I love how Microsoft took the approach of when we add this new feature, we're going to do it really gradually first and only introduce it for a niche feature like column store indexes. But now they're coming out to the public in 2019 with row store indexes too. I don't have any column store indexes in this database. The way that this query works, if I go look at the stored procedure up here, The way this query works is we're going to go hit the users table, and we're going to find all the people who have a specific reputation score. After we find them, we're going to go find all of the posts that they own. Well, reputation is an interesting column in the users table. Sometimes there are hardly any rows that match. Sometimes there are a spectacular amount of rows that match. Reputation equals 1 has a whole lot of people that match. And SQL Server needs to build one execution plan that's going to work in a variety of scenarios. Before 2019, it couldn't do this. But with 2019, it says, based on the number of users who come out of your reputation filter, I'm going to choose between a couple of different operations. This adaptive join will either do an index seek or an index scan, depending on how many rows came out of this arrow right here. You can see a little bit more about its decision-making process by hovering your mouse over the adaptive join. There's a new thing up inside here that says adaptive threshold rows. If the rows that come out of the user's query or user's join are way more than this, do the scan. If they're way less than this, do the seek. Now, both of the operations end up showing up inside my execution plan, but you can tell which one actually executed by hovering your mouse over it. If I hover my mouse over the index scan in this case, it said number of executions is 4. This was, I guess, parallelized across multiple cores. Now, if I hover my mouse over the index seek, number of executions in this case is 0. Because so much data came out of this index seek, SQL Server decided to do the scan instead. This is really cool because if I turn around and run it for reputation equals 2, now we'll see what SQL Server is going to decide to do with this one. Now, let me zoom in so you can see it again. Now, the number of rows that came out of here, notice that my stats still stay the same. Estimated number of rows is still 1 million. That's inherited via the parameter sniffing from the first time that this got called. But now, if I look at these two operations, if I hover my mouse over the index scan, number of executions is 0. Number of executions down on the index seek is like 1,800 because we had 1,800 rows come back from here. This is really freaking awesome. This is a tool that helps us do a better job of dealing with parameter sniffing. Because if a lot of data comes in, SQL Server can do one thing. If hardly any data comes in, SQL Server can do a different thing. This is not going in whole hog. There's a whole lot of things that SQL Server has to have to make decisions before it'll do this kind of thing. It doesn't work with updates and deletes. It really focuses on selects. It has to make a choice between an index seek versus an index scan. It's not a way to fix table scan versus index seek plus key lookup, which is frankly the biggest problem inside of parameter sniffing issues is when we have to choose between an index seek plus a key lookup versus a table scan. It doesn't do that, but at least it gives us a little bit more flexibility here between execution plans. So your life is now becoming a little bit easier when dealing with parameter sniffing issues. There's a catch, isn't there? Of course, there is always a catch. Now that does work, and it does go into the execution plan, but now I have a new problem. If I turn around and run it for, say, reputation equals 1, look how long it's taking. What's the holdup? Well, the holdup is our old friend, our new old friend, adaptive memory grants. See this thing here, the adaptive join? It is a new place where you're going to be facing tempdb spills. Here, operator used tempdb to spill data during execution. We wrote 93,000 8K pages to disk. If I go in to understand why, I'm going to go over here and look at memory grant info. We only desired 5 megabytes of RAM. Unfortunately, we needed more than that. One of the cool things about batch mode and adaptive joins is they'll actually add more memory while the plan runs, but they'll only add so much. Here, notice that I got, if you hover your mouse over the select, you get a warning, memory grant detected grant increase. Grant Fritchie walked into the plan and got his screwdriver out and started playing around with it live while the query plan ran. We got granted a little additional memory, but it simply wasn't enough. Well, hey, the nice thing about adaptive memory grants is that they adapt. So I should be able to run this thing again and it won't spill, right? 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 Not right. Now we wrote 60,000 pages to disk. And if I hover my mouse over here, I didn't get a grant increase, even though I did spill to disk. How's our adaptive memory grant working? Memory grant info, well, we got granted 18 megabytes. I guess that's better than it was. Let's go try it again, and let's see if maybe now we'll get enough memory that we can avoid the spill. It's running a little bit faster, and it's still spilling to disk. This time it only wrote 30,000 pages to disk. So I've got hope. I want to believe. Let's run it a few more times, and eventually we'll get enough memory that we're not spilling to disk. Now it's not spilling to disk. How much memory are we getting in order to avoid spilling to disk? 47 megabytes. Okay, that's cool. And it's stable, just like me. That's awesome. So everything will be completely cool as long as no one comes in and runs it for a tiny number, thereby throwing off our memory grants, because now if we run it again for reputation equals 1, wah, wah, wah. Now I told you that parameter sniffing becomes a whole lot harder in SQL Server 2019, even with things like this, like adaptive joins that are meant to help, they backfire as well. I'm not saying that they're bad and you should completely avoid them. It's just that they suddenly make your life a whole lot more unpredictable. And oh, I am only getting to the tip of the iceberg as to how unpredictable they make your life. Because see, all this last 5 minutes worth of demo that I just did on adaptive joins, they get even worse than this. What happens if I free my plan cache and then I run this stored procedure with 3 different reputation values? I'm going to run it with reputation 1, reputation 2, and reputation 3. Now I'm using with recompile hints on all 3 of these because I want to show you what plan would go into cache if you ran it with reputation 1 first, or 2 first, or 3 first. If the reputation 1 plan happened to go in the cache first, yes, you get the adaptive join that I've been showing you here. But if someone ran it for reputation equals 2 first, if you look at that query plan, ain't no adaptive join here. And the whole query goes single-threaded. If I run it for reputation 3 first, now I get no adaptive join, and the query goes parallel. Before, when you were dealing with parameter sniffing issues, you really only had 2 different plans to choose from in this query. Now you have 3, plus the challenges of adaptive memory grants. Your parameter sniffing issues just got exponentially harder because SQL Server has so many more choices to make. As long as it made consistent choices, we wouldn't have a problem. But you're going to be facing spectacularly unpredictable choices based on doing things like rebuilding your indexes every night and updating your stats every night. Because when you do those things, you are effectively doing this, freeing the plan cache. When you free the plan cache for either specific objects, tables, stored procedures, whatever, based on rebuilding indexes for those, if someone happens to run it for reputation equals 2 first, they just put the plan in memory that doesn't have an adaptive join. So now when we run it for reputation equals 1, you don't get the luxury of that adaptive join, and you can end up spilling to disk out the wazoo, doing way more reads than you needed to because of this index seek type operation. It's all going to be a dice roll as to what plan happens to go in first. Now, I don't want you to think that I'm not gung-ho on SQL Server 2019. I'm wildly gung-ho on SQL Server 2019. There are all kinds of things that are really cool inside of this. The table variables generally just get better. Scalar user-defined functions just get better. We get nearly instantaneous rollback with accelerated database recovery. So many cool features. The thing is, it's just that Microsoft is giving you more guns in this version. More guns that if you don't quite understand them, you will shoot yourself in the foot. And as a consultant and trainer, I love it when you shoot yourself in the foot. So you can learn more about all this over at brentozar.com/go/what's new, where I've got these exact demos that you can go play with, plus links to the Stack Overflow database to go download, and links to the rest of my posts about SQL Server 2019, what's new, and how you can work around some of these features.